فصلوا على خير البشر. اللهم صل وسلم وبارك على محمد وعلى آل محمد رسولنا النبي الأمي المبعوث رحمة للعالمين.
That's kind of cool here. Let me go into the extensions button at the bottom left of my screen. And this one's kind of cool. Let me go to text to speech. And you'll notice that this one requires internet because it's cloud-based. But this just gave me some new puzzle pieces in a new category, text to speech. And these green ones do exactly what they say. So let me do this. Let me zoom out again. Let me keep the join block, and I'm just going to temporarily toss it over here. It's not going to delete itself because I didn't drag it over to the other side. But I'm going to get rid of the say block in purple. I'm going to do the speak block here in green and let it snap into place. And then I'm going to drag and drop this onto the input to speak. And now, perhaps a little more adorably, let's try this. Green flag. What's your name? D-A-V-I-D. Enter. And?
Hello, David.
OK. It's a little robotic, but at least now it has synthesized speech. And I've kind of got my own like Siri or Google Assistant or Alexa thing going on here now, where it's now recognized whatever text it is and it's played it. Well, let's make this an actual cat that doesn't talk in that weird human voice. Let me go ahead and get rid of most of this stuff. And let's get the cat to actually meow like a cat tends to. And let me go under the sounds block. Now, MIT gives you a few sounds for free because it's designed around a cat by default. And I'm going to go ahead and grab this one. Play sound meow until done. And now, and we heard a teaser for this earlier in the crowd. It's a little piercing, admittedly. We can lower the volume a little bit there. But notice if I want the cat to meow a second time, I'll just click it again. OK, and over there too, I hear. OK. All right, so it's kind of cute now, right? So it's just meow. OK, yes, echo, echo. So it's meowing now every time I hit the green flag. Now, that's great, but even a kid is probably going to would prefer that it just meow, perhaps, like again and again without having to keep hitting the button. So well, how might we do this? All right, well, if I want it to meow multiple times, why don't I just grab it another time and another time? Alternatively, you can right-click or control-click a puzzle piece and just duplicate it from a little menu that drops down. So here we go, 3 meows. All right, that's not really a happy cat, it sounds. Maybe hungry. So can we slow that down? Well, maybe. In fact, if I poke around, let me go under control. Looks like there's a wait block. Wait 1 second by default. And notice, Scratch will be pretty accommodating. If you just hover in between blocks, it will grow to fill that too. So I could change it to 1 or 2 or anything seconds. I'll just leave it at the default for now, 1. And now I'll go ahead and do this. OK, so cuter and less hungry and just more friendly. But this isn't the best design. It is correct. And let's use that as a term of art. Correct means the code does what you want it to do. I want the cat to meow 3 times, slowly, and it did. So I'd wager this is correct. But it's not the best design. And this is where things get more subjective, right? Like you could write accurate sentences in an essay for an English class, but otherwise it's just completely a mess. Like your arguments here and there, and you don't say anything wrong, but you don't say it well. In the context of code, we can do better than this. And copy paste or repeating yourself again and again tends to be bad practice. Why? Suppose that you want to change the wait to 2 seconds instead of 1. It's admittedly not a big deal. Fine, I click there, I change it to 2. I click there, I change it to 2. But what if you meow 5 times, 10 times? Now I have to change the wait like in 5, 10 different places? Like that's just stupid. It's taking unnecessary human time. And you're going to screw up eventually. Especially if your program's getting longer, you're going to miss one of the inputs. You're going to leave the number wrong, and that's a bug. So just based on what you've seen already, or if you've programmed before, which a few of you have, what's the term of art here that will solve this? How can we design this better? I heard it here. Yeah, so a loop, some kind of cycle that says do that again, do that again. Not infinitely many times necessarily, but some finite number. Well, you can perhaps see a spoiler on the screen. Under the same orange control category is a repeat block. And by default, it's proposing 10, but we can change that. So let me do this. I'm going to throw away most of this copy-paste as redundant. I'm going to detach this temporarily just to make room for something else. And I'm going to drag a repeat block over here and let that snap into place. And I'm going to change it for now just to be 3 for consistency. And this is the correct shape, even though it's too small, but Scratch will accommodate that for us. And now, same output, but arguably better designed. Why? Because if I want to change the number of meows, I change it in one place. No copy-paste messiness. If I want to change the weighting, one place. I don't have to change it in multiple places and not screw up. So let me hit the green flag. right, so nice. Now, it would have been nice if MIT had just given us a meow block that just automates all of this for us. Let me wager they gave us the low-level implementation details. They gave us the play sound meow. But I had to implement like a decent number of blocks just to get a cat to meow again and again. I feel like we should have gotten that for free from MIT. Well, they don't have to be the only ones that invent blocks for us to use. You can write your own functions, your own verbs or actions. So how can we do this? Let's make our own puzzle piece called meow that uses this code but creates it in such a way that it's reusable elsewhere. So let me do this. Under my blocks in pink here, I'm going to go ahead and click literally make a block. Now here's an interface via which I can give the block a name. MEOW will be the name of this block. And I'm just going to go ahead and quickly click OK. That just gives me a very generic pink puzzle piece that starts with the word define, because Scratch is asking me to define, that is, implement or create this new puzzle piece for me. Well, what does it mean to meow? I'm going to claim that it means to do these two steps, to play the sound meow and then just wait for 1 second. But what's powerful about this idea is look at this up top. Now that I've made a block, it exists in Scratch. MIT didn't need to create this for me. I created it for myself. And even you, if we end up sharing code. So I can now drag meow up in here. And what's nice about meow is that itself is, yes, a function, but it's also an abstraction. Like never again do I, or even you, need to worry or care about what it means to meow or implement it. I can sort of drag it out of the way. I didn't delete it. Drag it out of the way, out of sight, out of mind. Why? Because my code is now even better designed in some sense because it's more readable. What is it doing? When the green flag is clicked, repeat 3 times, meow. It just says what it means. And so it's a lot easier to read it, and it's a lot easier to think about it, especially if you're using meow in other projects too. Now, let me go ahead and hit click play. Same thing. So it's not really fundamentally any different. But I can make this custom puzzle piece, this own function of mine, meow, even more powerful. Let me kind of rewind a bit and go to my meow puzzle piece. And I am going to control click or right click on my pink puzzle piece. And I'm going to edit it. So I kind of regret making meow so simple. Wouldn't it be nice if meow took an input, aka an argument, that tells meow how many times to meow? Then I can get rid of that loop and just tell meow how many meows I actually want. So I'm going to click on another button here called literally add an input. And it's going to have placeholder here. So I'm just going to put a placeholder there. I keep using n for number, which is a go-to in computer scientist terms. And I'm going to add some descriptive text just so that it's a little more self-explanatory. I'm just going to say meow n times. But there's only one oval. Times is just going to be explanatory text. And now notice what has happened. Now my puzzle piece takes an input, aka an argument, that will tell that function to meow some number of times. But it's not just going to work magically. I need to implement that lower level detail. So let me zoom out. I have to remind myself what this function was. So I'm going to drag it higher up just so they're on the screen at the same time. I'm going to go ahead now and temporarily move this over here. I'm going to temporarily detach this over here. Why? Because what I think I want to do is move my loop into the function itself, move the play and the wait into the loop, but I don't want to hard code 3. Notice that n here is its own oval. I can drag a copy of n and just let it go there. So now I have a new version of meow that takes an argument, n, that tells meow how many times to meow. And now, let me again drag this out of sight, out of mind, because who cares how I implemented it? Once it's implemented, it's sort of done. Now my program is even better designed in some sense. Why? Because now it really just says what it means. There's no loop, there's no repeat, no like implementation details. When green flag clicked, meow 3 times. And so functions indeed let you implement algorithms, like they're just code that do something for you, but they're also themselves abstractions. Why? Because once a function exists, it has a name, and you can think about it in that term, and you can use it by its name. You don't have to care or remember how the function itself was built, whether it's by you or even MIT. So again, here, I'll click the green flag. It's the same thing. So still correct, but better and better designed. And so anytime here and out with Scratch, or soon C, and eventually Python, when you find yourself doing anything resembling copy-paste, or again and again grabbing the same code, probably an opportunity to say, wait a minute, let me refactor this, so to speak. That is, rip out the code that seems to be repeated again and again, and put it in its own function so you can give it a descriptive name and use and reuse it. Any questions just yet on now saying, or these loops, or these functions that we're using? Yeah. How did I make it so it meows 3 times? So I originally only had a puzzle piece called meow, and I decided to improve it. So I held down Control, and I right-clicked or Control-clicked on the pink puzzle piece at top left, and I clicked Edit. And that brought back the original interface that lets me add some arguments to the puzzle piece itself. And I clicked Add an Input on the left here, and then I clicked on Add a Label over here. So that just lets you customize it even further. All right, so we've done this. Let's add one of those other primitives too, to do something optionally. So how about we make the cat meow only if it's being petted by a human, as by moving the mouse to hover over the cat like a human would pet a cat. Well, let me go ahead and throw away the meowing for now. And let me simplify it by just using a sound. I'm going to go ahead and do this. I'm going to go ahead and have a control block that says if, because I want to implement the idea of if the cursor is touching the cat, then play sound meow. Or I could use my same pink puzzle piece, but I'm going to throw that away and focus only now on the sounds. And I'm going to do this. If touching mouse pointer, so I need to sense something about the world. And we saw this earlier. So if touching mouse pointer. So notice this shape here, way too big, but it is the right shape. So if I hover just right, it'll snap into place. And this now in blue is my Boolean expression, a yes/no question, true, false. If is a conditional. And what do I want to do? Well, if the cat is touching the mouse pointer, I want to go ahead and play sound meow until done. So let's do this. I'm going to hit green flag, click. Now nothing's happened yet because it's a conditional, right? It's only supposed to do something if I'm touching the cat. Let me move the cursor over to the cat and wait for it. Another bug. Why is the cat not meowing? Even though I very explicitly said, if touching mouse pointer, meow. Yeah, in the middle. Yeah, this is, again, my computer's just so darn fast. Like yours, I click the green flag. It asks the question, am I touching the mouse pointer? Well, no, because my cursor was up there, not touching the cat. It's too late. The cat's out of the bag. And so we have to instead solve this by some other means. How can we fix this? How do we fix that sort of race? Yeah. Yeah, so why don't we just keep asking the question until I eventually am or am not actually petting the cat? So let me detach this temporarily. Let me go under Control. Let me go under, instead of repeat some finite number of times, let's just do it forever. So sometimes loops that do work forever are a good thing. Like the clock on your phone, that's in a loop forever because you want it to always tell time and not stop at the end of the day. So sometimes you do want code to loop forever, as in this case. So let me go ahead and drag and drop it there. Let me again click the green flag. Nothing's happening yet, but notice the program's still running. And so if I move my cursor, and oh, OK, so maybe we could add some waiting, but the cat does not want to be pet in this case, but it's indeed conditional. So there we have an incarnation in Scratch of doing something conditionally. Now we can make this really cool, really fast, if you will. Let me stop this version. Let me go ahead and do this. Let me go ahead and throw all of this away. Let me go into my little extensions bucket over here. And let me do video sensing, since most laptops or phones these days have cameras. And there, indeed, I am with Sanders behind me. And let me do this. When video motion, and let me get out of the way. When video motion is greater than some value, so 10 is the default. This is just a number that measures how much motion there is or isn't. So small number is like no motion. Big number is lots of motion. So I'm going to choose 50 somewhat arbitrarily here. So 50. This is not normal to program off to the side. But I'm now going to say this. When video motion is 50, go ahead and play sound meow like this. So the cat is still in that world. I'm going to stop the program and rerun it. So here we go, green flag. And now, here come, all right, this is a little creepy the way I'm petting the cat, but, and, OK. There we go. OK, so 50 was too big of a number. I have to pet the cat faster. Whereas this, if, I don't know. Yeah, so, OK. So you can make things even more interactive in this way by just assembling different puzzle pieces. And honestly, there are so many different puzzle pieces in here. We're not going to even scratch the surface of a lot of them. But they generally just do what they say. And indeed, when you see on the screen here, This palette of puzzle pieces, really a lot of programming, especially early on when learning a language, is just trying different things and try and fail. And if it doesn't work quite right, look for an alternative solution there too, as even I just had to do a moment ago. Well, let's go ahead and use actually, how about another example of something a predecessor of yours made? Let me go ahead and grab a program I opened in advance here called Whack-A-Mole. Might we get a brave volunteer to come up who is willing to whack-a-mole with their head virtually? Maybe. OK, let's see. How about in way back? You want to come on down? All right. Come on down. And in just a moment, sure, round of applause for our volunteer. All right. So here we have. Come on down. Okay. What's your name?
I'm Josh.
Oh, actually, say it into the microphone.
Hi, I'm Josh.
OK, nice. Welcome, Josh. Come on over. All right. So same idea here. I'll take the mic back. You'll have to stand in front of the camera. In just a moment, you're going to have to position your head in a box that your classmate from yesteryear created. And we'll start with beginner.
Okay.
So line your head up in the box in a moment.
All right, all right.
Nice. 12 seconds. Five seconds. Notice the score is up to 18 already. Pretty good. All right. A round of applause for Josh, if we could. So notice how using some fairly simple primitives, things do get interesting pretty fast. And how was that implemented? Well, there were probably at least 4 sprites. So you're not confined to just one cat. You can create more and more sprites, change what they look like so they actually look like a mole in this case. There's probably some conditionals in there, some loops for 30 seconds. That's checking if Josh's head's movement is exceeding some value over this way or over this way, then increment something called a variable. We'll see those too. Just like in algebra, you might have x and y and z storing values like numbers. So can computer programs have variables called x or y or z, or more descriptively called score, as in this case at top right, or another variable called countdown, typically one word in code, but in this case 2 words, that just store some value. So there's probably some math going on in there whereby the author of this program just is incrementing, that is adding 1 and 1 every time it detected that a mole had been whacked, in this case with movement.